Hello students, and welcome to another video. I'm your teacher, Mr. Flynn, and today we're going to be talking about how do we pronounce chemical formulas. Okay, so a chemical formula is our list of atoms and the numbers of atoms found in a compound or in a molecule if we're working with covalently bonded atoms. For example, like nonmetals that are combining to form molecules. Okay, but when we're thinking about how to name, I want you to think of breaking it into two parts. Okay, so if you look here, these are all just combinations of different metals, nonmetals, polyatomic ions, transition metals, etc. And I'm going to go through and talk about each of these, and then we're going to build them together. Okay, and at first it's a little tricky, but once you get some practice behind it, it starts to make sense and it all comes together. So we're going to be referring to this blue sheet pretty frequently. So have it sitting next to you, have it out, and I will draw onto this. Okay, but let's break down the four different parts. So we have four elements that kind of want to make bonds with each other. Let me pull out a piece of paper here. All right, so we've got four parts. All right, we've got monoatomic ions. Okay, and the term monoatomic ions kind of is, we don't really need to give a definition for it because it kind of tells us what it is. So mono is meaning one, atomic is referring to atoms, and ions is an atom with a charge. So it's basically atoms that are by themselves with a charge. And we have two types of these. We have, actually technically three, but the main two are metals and nonmetals. All right. And when I talk about metals, I'm talking about main group metals. And main group metals consist of groups 1, 2, and 3, and even into 4. But if you look here, we have 1, 2, 3, 4. And we call this the transition block or transition metals because we're transitioning from 2 to 3. Can you see that? So these ones here in the center, we call those transition metals, and I'll talk about those in a moment. Okay. But the idea here is that when we're working with 1, 2, 3, or 4, I guess, main group metals, okay, when we write them, we'll write it like this. So this, Na, is sodium. Okay, it's neutral, it doesn't have a charge, so it's not a monoatomic ion. But we know that main group metals are going to be giving electrons away. So if it gives an electron away, it's going to have a charge. So now this is a monoatomic ion, specifically a metal, which gives electrons away. And we know this because sodium belongs to group 1. Magnesium belongs to group 2 and will give 2 electrons. Aluminum will give 3, etc. Okay? So when we write this, we're going to write the name of the metal, sodium, and then we're going to write the word ion at the end. So I pronounce this as sodium ion. Okay, it's pretty straightforward. You just look at it and say sodium ion. Right? If we had Mg, magnesium, right, this is magnesium, but if it's got a 2+ charge, we now call it magnesium ion. Okay, pretty straightforward, right? This was the easiest one to do. Now, nonmetals are a little trickier. Okay, let's say we have something like chlorine. Okay, by itself, it's chlorine because it's neutrally charged. It's not an ion, but we know that nonmetals are going to be takers. They're going to be taking electrons. So if they take an electron, okay, it's going to have a negative charge. So now this is a chloride ion. We have to do a little bit of adjusting to this. It's not just chlorine ion like metals are. So we have to add ide, plus we have to add ide to our thing. So we're going to have a chloride ion, right? And we have ion because it's got a charge, right? And we're going to make some adjustments to chlorine and add ide to it. So let's do another one. Let's say we have fluorine. Actually, yeah, we'll do fluorine. All right, so we have fluorine, and its charge is F negative, and I pronounce this as fluoride ion. Ion, like that. Hold on, give me 1 second here. Okay. All right, so we've got metals and nonmetals, and specifically main group metals. All right, and this is how we're going to pronounce them. So if we see a lone fluorine or a lone chlorine, it's chloride, fluoride, and they're both ions. Here we have, our next one is a transition metal. Okay? And we know from our group numbers, okay, our Roman numerals, that we know how many electrons each of these atoms are giving away. But there's nothing telling me how many of these atoms are giving away. So transition metals kind of are atoms that don't have a set number. I guess they each have set numbers of electrons to give away, but they can give different amounts of electrons. So if I look at my variable cation list, it's right in the middle of my blue page, I can see that gold can give away 1 or 3 electrons, copper 1 or 2, iron can give away 2 or 3. So if we're looking at these, we cannot know which one it's giving away. So we have to signify how many they're giving away. So for example, if I have iron, Fe, right? This is iron, okay, it's neutral, but typically we're not going to find iron in a state where it's going to be neutral. So it's going to be 2 plus, right? So it's going to give 2 electrons away. I would signify this as iron 2, okay? And then if we had Fe3 plus, this would be iron 3, and I'd write my Roman numerals in there, okay? Let's just say I had lead, okay, Pb, and it gives away 4. I would write lead 4, like that, okay? Because lead can give away 2 or 4. You see that? All right, so we have to signify how many they're giving away. Okay, so these are our 3 that we're most probably familiar with, at least what we've dealt with so far in this class. And then this new concept is called polyatomic ions. And there's a full list right here of all of our polyatomic ions you know. So I grouped them by charge. So these are -1, -2, -3, and then this is a +1. Now there's some significance to why I want you to memorize these, okay? For at least for some of my classes I'm having you memorize. If I have not told you to memorize them, don't, okay? But for the most part, if you're watching this video, you're most likely going to have to memorize these. And it's helpful, even if I've not asked you to memorize them, because you're going to see them throughout the rest of this year, and you know that they're little groupings, okay? So let's just look at the very first one. We have acetate, and we have C2H3O2. And we know that they're all covalently covalently bonded because they're all nonmetals. Okay, they're nonmetals that are bonded together. Okay, and the reason it's not a molecule is because it has a charge. So it's poly, meaning many, atoms, and they have a charge. So we have many atoms with a charge. That's what that title means, right? So we have something like chlorate. It's ClO3 with a negative. And I want you to imagine that these polyatomic ions are going to act just like regular charged atoms. So for example, for a polyatomic ion, we have, we'll do this, C2H3O2, and its charge is negative. Okay, another element that has a negative charge is chlorine. Right? So acetate and chlorine are actually going to act the same, except for polyatomic ion of acetate is going to have more than one atom. So we know that sodium chloride is formed when we have NaCl. But what if we did this? Could that work too? Yeah, that works because we have sodium acetate. It's recognizing that these group of atoms have a charge and now they're bonding ionically with sodium, and just like chlorine is. So you can treat these just like regular atoms with charges. So treat them the same, just know that they're in a group. Okay, they're not a molecule, they're a polyatomic ion because they have a charge. Okay, if it did not have a charge, this would be a molecule. Okay, like water, because water, H2O, does not have a charge. We call this a molecule. Okay, all right. These are our 4 players in our game. We have metals that are main group, transition metals, and then we have nonmetals and polyatomic ions. And they're going to form various relationships with each other, and we're going to talk about how do we name them and how do we balance their chemical formulas for each one. Okay. So I'm going to put this off to the side. So keep this out and look at it. Refer to it as we talk about these. And I'm going to go through these just one by one, and I'm just going to talk about it on this page. All right? I'm just going to show you how to use it. Okay, so if we have a main group metal and a non-metal, okay, and it gives you some instructions here, and you can actually use this on your test, by the way. So don't lean on this like a crutch, but I want you to take the time to really understand it so you can use it as a tool as you're like, oh, I cannot remember how to draw this out. And this will help you as you name, and you'll get better at it. Okay, you're gonna have an assignment that has lots of these for you to practice. Okay, so if you have a main group metal, probably group 1, 2, or 3 mostly, and what you're gonna do is you're just gonna combine that with a nonmetal, like NaCl, it's the one we just talked about, and you're just going to list out the metal, and you're going to add I to the end of your nonmetal. So nonmetals, you're going to find that they're always listed second. Main group metal, nonmetal. Main group metal, polyatomic ion, transition metal, nonmetal. Okay, and then when you're mixing nonmetals, they're going to, obviously, there's not a first or a second because they're the same. So you'll always list your nonmetal, the takers, last. You'll always list the givers first. So lithium is a giver, and it's going to give electrons to oxygen. And we're going to call this lithium oxide. Okay, we're going to name the metal, and then we're going to add I to our oxide. Okay, and the reason we do this is because oxygen originally was an ion, but now we dropped the ion part because there's no ion here, right? That doesn't exist because now they're balanced on their charges. And let's talk a little bit about why there's 2 lithiums and 1 oxygen. Whenever we look at a relationship between 2 different entities here, we need to understand that someone's defining their relationship, and oxygen is the one defining it. Because if we look here, if we had 1 lithium, if I wrote it something like this, LiO, right, in the middle of my page, right, we know that oxygen is going to take 2 electrons. Okay, lithium can only give 1. So right here we see an off balance. They're not giving the same number of electrons. There's an electron that we need to satisfy oxygen. So we need to have 2 lithiums. So now we're going to have that second one there. Our charge is balanced. It goes from +2, -2, and we now have a balanced compound. Okay, and that's why aluminum, aluminum is going to give away 3 electrons, and bromine can only take 1. If we look at our table, and that's why we have 3 bromines. And I would just pronounce this as aluminum bromide. Okay, you do not need to tell me how many bromines there are. You just say aluminum bromide. Okay. Same with lithium oxide. You don't have to tell me how many there is. Just say, well, that's lithium and oxygen, and it's up to you to balance it when it works out. All right. All right. Comes off there. All right. Let's do the next one. Now we have a main group metal and a polyatomic ion. Now this one's probably the easiest one because all you got to do is just say what it is, right? So this one, we have calcium, and then we have CO3. Right? And if I flip this over, CO3 is right here. It's carbonate, and it has a -2 charge. So it's going to act like oxygen will, right? Because oxygen has a -2 charge. So it's going to act something like oxygen. So carbonate is going to take 2 electrons, and calcium, how many can it give? 2. So it matches up. It lines up pretty well. So we're giving 2, taking 2. And we just name it as calcium carbonate. So this is balanced, okay? And then below we have magnesium and acetate. But the thing we know about acetate is that it has a -1 charge. And we know that magnesium is going to give 2 electrons away. And acetate can only take 1, so we need to have 2 of them so they can take 2 electrons. So it balances out. So you always got to make sure your electrons balance. Okay? And all you got to say is magnesium acetate. You don't have to change anything. You just read it. Calcium carbonate, magnesium acetate. You do not need to tell me how many there is of each kind. Okay? So as you look at these, you're just going to recognize that C, A, C, and O3, you'll start to piece together that this is where the separation is. And then you'll recognize this is where the separation is. It takes time to recognize what is part of what. Okay? All right. Now, let's get into transition metals. This one gets a little trickier. And I kind of group these together, nonmetals and polyatomic ions, because they follow the same rules as main group metals. So I'm kind of grouping it together. So right here, we've got copper and sulfate. Okay, you see here, this is where our relationship draws that line is in between copper and sulfate, And we know that copper can either give away 1 or 2 electrons. So it's variable, okay? So it's hard for copper to define the relationship because it doesn't know how many it's giving away. But we do know that SO4 sulfate, if we flip this over, sulfate is going to have a -2 charge. So it's going to want to take 2 electrons, okay? And the reason I'm going through this quickly is because I know these. Okay? If you don't know these, you may want to pause the video, get to know them, all right? And then come back and watch this video, okay? Because I'm going through this pretty quickly, all right? And I want you to make sure you know these. And I'm just going to start listing them off. So we have sulfate, and we have SO4 at -2. All right, so we know that sulfate is going to take 2 electrons each, okay? Each of these sulfates are going to take 2 electrons. So now how many electrons can copper give to satisfy that 2? Well, if we have 2 coppers, it's like this, Cu, Cu. Each one is going to give 1 electron. So that's why we call this copper 1 sulfate, because there's 2 coppers and each of them are giving 1. So 1 copper atom is giving 1. This copper is giving 1, right? And down here, if you look at this one, it's copper 2 sulfate because there's only 1 copper, and we know that this copper can give 2 away. Okay, so we're balancing out our charges. It's getting a little messy, so let me clean this up a little bit. Okay, and if I look at this, it's very tempting to say copper 2 sulfate. Is that the case? That is not the case. There is 2 coppers and each one is giving 1. In this instance, you could say copper 1 sulfate. It's not. It's 1 copper giving away 2 electrons. This Roman numeral is telling me how many electrons are being given away. And you have to know how many copper atoms there are and how many each one is giving away. Okay, pretty straightforward. Now the next one, it's a little easier. Copper chloride. Okay, we know chlorine, it's going to take 1, but there's 2 of them, so this is going to want to take 2 electrons, okay? And in this copper, there's only 1 of them, so it's going to give 2 away. So it's going to be copper 2 chloride, right? And we add the "ide" to the end because with our nonmetals, we tend to add "ide" to the end, and when we put it in a formula, because this was an ion, okay? All right. If you've got questions, come talk to me about this. But overall, the instructions are right here. It goes through it and explains to you. But you need to know how many is each copper giving. That's what this Roman numeral is signifying. Okay? And they do not define the relationship because they don't know how many they're giving. You've got to look at what it's combined with and see, oh, sulfate has 2 electrons it needs, and this one has, how do we give 2 electrons over here? Okay? All right. Now, let's talk about nonmetals and nonmetals. Okay, this one's not too challenging. But it's just about recognizing 2 nonmetals coming together to form a molecule. And this is a common one that you're already familiar with, carbon dioxide. You see this and you just say it, right? And there's a couple rules with this. You need to signify how many atoms there are in each of these. Okay, it's the only one where you have to do some counting. But if you look at this second example, let's look at this one. We have 2 chlorines and 7 oxygens. Okay, and you notice the prefixes here is dichlorine hept oxide, right? And if we look at this, we're seeing that we're signifying how many there are. And I have a list on the front here of prefixes that you can use. So if it had 8, you would write octoxide or hexoxide, pentaoxide, tetraoxide, okay? As you're working through numbering them, okay? And carbon dioxide is kind of special because carbon, do I need to write monocarbon dioxide? I do not. I just say carbon dioxide. If it just has 1 up front, just name it carbon. This one has 2, so you can't just say chlorine. You have to say dichlorine. But if it was just a single chlorine, I would just say chlorine heptoxide. But because there's a 2 there, I need to say dichlorine heptoxide. Carbon dioxide, because di is 2. And you'll notice that the ending is just like we've done with everything else. We add "ide" to the end because it's showing us that these were ions and now they're forming a neutral compound, or in this instance, a molecule because they're covalently bonding. Okay? So if you've got more problems with this, come talk to me. But start working through your practice. If you start working through the practice problems and I kind of help you with those, it really goes a long way, you practicing this. Because that's the only way you're going to know this is all through practice. Okay. The last thing is acids and bases. So does the compound start with an H? Well, it's probably an acid. And if it's an OH, it's probably a base. And OH, if you know your polyatomic ions, right, OH is called hydroxide, all right? And if it ends in an OH, it's probably a base, sodium hydroxide. and it starts with an H, H2SO4. This is sulfuric acid. And I do not expect you to know the naming rules for these. They're already given to you. They're right here, acids and bases. And we're not going to work with these a lot until later in the year, but it's good to be able to recognize what's an acid and what's a base. If you look at our bases, they all end in OH. And if you look at our acids, they start with H's. Okay? And that's kind of the main idea. All right? There are a few over here that start with H, and I threw them in the polyatomic ion list. Okay? But keep in mind that if it starts with an H, most of them are most likely going to be somewhere in this category. Okay? So we've covered almost everything on this blue page: polyatomic ions, variable cations, acids and bases. We've talked about the prefixes. You should know your Roman numerals. Okay, diatomic molecules. All right, these right here. When in nature, we will not find these elements by themselves. They're going to exist in pairs, and we'll talk more about this when we get to chemical reactions, and we'll talk more about it. But for now, just kind of keep that in the back of your mind. It's not something you have to worry about right now. Okay. And then lastly, we have these here. And these are my variable cations. So these are our transition metals. Okay. Right here, transition metals. And then right here, we have our fixed anions and cations, right? Because anions are ions that have a negative charge, and fixed cations are atoms with a positive charge. And we know that the halogens and group 6 and 7, or group 6 and 5, okay, are all going to form compounds like -1, -2, -3, and that's right here. And then we have our metals, which are our alkali metals and earth metals, which is groups 1, 2, and 3. All right, I didn't include group 3 in there, but you get the idea, because aluminum's in here too. Okay, and then cadmium, zinc, and silver, they exist in the transition block, but they only have one option. Like there's no silver 1, silver 2, like there is gold 1 or gold 3. So learning to recognize these fixed and variable cations will take time and will take practice. You do not have to memorize these. These are all going to be given to you. Okay. The only thing I expect you to memorize on any of this paper is probably the polyatomic ions, and that depends on what class you're in. Okay. So this will always be available to you to use. So it's just a matter of learning to use your resources in this class. Okay. All right. I think that's about everything. If you've got questions, this is a hard subject. Okay. This is kind of where chemistry in my mind begins. We've been talking about all the concepts, and now we're building up to actually working with formulas and working with problems and how do we name these compounds. Okay, this is where it gets challenging. So be patient with yourself, and if you need help, come talk to me. Let me see if I can get you the help you need to be successful. Okay, thanks again for watching. Until next time.